Guys, hey guys, so if you're watching this, that means you made it past the first one and the first exercises. Yay, I'm so happy. Okay, so let's move on. To start with, I already got these two graphs here, so we're gonna analyze them, okay? As we learned, this is a positive graph, this is a negative graph, okay? If we analyze the exercises before, we're gonna notice that in the standard form equation ax plus squared plus bx plus c, we had a graph like this when our a was positive, and we had a graph like this when our a was negative. Remember, a is the number that is in front of the x squared. So in this case, we had negative x squared plus 4x minus 1, and this was the graph we got, negative 1. Okay, and then our second example was positive x squared minus x minus 2, and this was the graph we got. So the a in the standard form equation is the constant that's gonna determine whether your graph opens upward or downward, okay? So a positive graph opens upward, and a negative opens downward. Now, if we had to analyze this whole situation, we would realize that in both cases, we had this point where it stops declining and starts inclining again, and it stops inclining and starts declining, okay? If you think of a roller coaster, that would be the point where you stop going up and start going down, and vice versa, all right? So, what do we call this point, this specific point that's here, down here in this one, and up there in that one? So in this case, it is called lowest point, or minimum, most widely known as minimum. In this case, it's called the highest point, or most widely known as maximum. So this is a point which is the lowest point in your whole graph, and it's called minimum if your graph is positive, and this point is going to be the maximum or the highest point if your graph is negative. We call both of them, both the minimum and the maximum, because they are one specific point. We call it the vertex, okay? The vertex. So both the minimum and the maximum are going to be called vertex, okay? And through that vertex, we're going to have an axis of symmetry that passes through it. What would that be? It is a vertical line. This is the axis of symmetry here, and this is the axis of symmetry there. In theory, this axis should divide your graph into two equal parts. So if you got the graph, it's like this, and you fold it in half, both parts would be right one on top of the other. Of course, that this is just a sketch, so obviously it's not actually very symmetric, but they should be. This one looks more symmetric, okay? if you fold this through the axis of symmetry, you should have one on top of the other exactly. Okay? So this is what the vertex does. And it also gives us the point where your graph and your movement is changing. So continuing in a few seconds, because I'm writing some things down, you take a look at how does the vertex work. Hold on. So moving on, let's think that the vertex is composed of an order pair, because the vertex is a point, right? It's the minimum point here, and it's the maximum point here. So how do we know what order pair is this guy? So there is a specific equation for the vertex, okay? So we're gonna have this specific equation that's always gonna be the same for finding the x. Oh my god. So to find the x coordinate, we need to replace the equation above with corresponding constants. So this is the reason, the first reason why we have to identify who's A, who's B, and who's C in every single function we get. So for example, example 1, let's say I have these function here. First thing we're gonna do is analyze who's A, who's B, and who's C. So A is 1 because there's nobody here, so it's always 1. B is positive 2. C is negative 4. So we need this. To solve, we're gonna replace A and B in this equation. That's always going to define the vertex. So we're gonna find the x coordinate for these order pair. Okay? So let's do this. We're gonna call xv for x vertex. Instead of calling, let's say it's xvyv, so it makes your life easier. So the x vertex is gonna be negative b over 2a. Okay. So who's negative b? B is 2, so it's gonna be negative. In the place of B, I'm putting the value for B. So I'm changing B for positive 2. Remember to use parentheses. So over 2a. Who's A? In this case, my A is 1, so alright? Now the x vertex is gonna be negative is positive negative 2. 2 times 1, 2. Can I leave it like this? Let's simplify. So I have this equation for the x vertex, so the x coordinate for the vertex, which is the point of minimum or maximum. I have this equation, this formula, it's always going to be the same. I have one sample function here that I have chosen, I'm giving you. I have identified A, B, and C, replace them here, so I found the x vertex. So now my point V is to find the y vertex. We replace the x vertex in the function. So my original function is y equals x squared plus 2x minus 4. And I know that xv is -1. So instead of writing x, I'm going to write xv. And instead of writing x, I'm going to write xv. Replacing. Use parentheses. This is a multiplication. So I'm changing the x's for -1, which is my xv, because I'm looking for yv. -1 squared is going to be +1. Positive with negative is going to be negative. 2 times 1, 2, minus 4 yv. This is -5. So I found that my vertex, which was x vertex, y vertex, now it is -1 that I had already found, and -5 that I just found from replacing the xv from the formula in my function. Okay? Is that hard? Hope not. Okay, so now we have, actually, we know which point is the point where the parabola stops growing and starts decaying. Now, let's go back. My A, in this case, is 1. Means that it's bigger than 0. If my A is bigger than 0, the parabola is going to be like this. So this vertex is a vertex of minimum. It will be this point over here. Probably underneath. It's all negative, so my graph is drawn wrong. It's going to be something like this. Okay? Alright. So now I'm gonna assign some exercises. If you're still in doubt, you can always go back and do again. Alright? Thanks for watching. See you.